Hi, welcome to another informative episode of Business School here on Business Access TV. I am Lance McFarlane from Sophomore Academics and I'm a math teacher, and today we'll be looking at variation. Alright, so we'll just be talking a little bit about variation. This is a topic that is taught generally. It can be taught anywhere between the third form to the fifth form stages in high school. Alright, so it's not difficult, even a first former can understand, so it doesn't matter. Just join us, pay attention. Alright, so we'll be looking at the two types of variation that we generally look at for these exam questions, right? Direct variation and inverse variation. Alright, so there's a slight difference. They are like opposites. Alright, there's a slight difference between them, and calculating them, it's not really difficult. It is all going to boil down to really and truly finding what we call the constant of variation. Alright, okay, you'll see that in a little bit. But variation, what exactly we're talking about? Variation. Alright, ladies and gents, this topic is really just looking at the behavior, the relationship between two variables. Alright, let me use an example, for instance, something that most of you are already familiar with. Let us look at the area, look at this equation. The area of a circle, you guys know the formula for the area of a circle, right? The area of a circle is equal to, what is called? Pi, all right, spelled Pi, times r squared. All right, so ladies and gents, looking at this equation, we have how many variables here? We have two variables, ladies and gents. We have the area of the circle and we have the radius of the circle. All right, you guys, so this is a circle, for instance. You know that the radius is the distance from the center to the circumference. All right, now this equation describes the relationship between the two variables, the radius and the area. Variables meaning the values can vary. All right, the values can go up or it can go down. We don't know. Every circle is different. So this is the radius. And what happens is, the larger the radius, then the larger the area of the circle. So if the value of the radius goes up, let me use a different color marker. If the value of the radius goes up, what happens to the area of the circle? It also goes up. And if the value of the radius goes down, then the value of the area will also go down, right? So this is what we call direct variation, where the two variables are going in the same direction. So increasing the value of one variable will increase the value of the other variable, or decreasing the value of one variable will decrease the value of the other variable. And guess what? The relations, that's a different topic as well in math. Well, these equations are all relations, but we'll get there. The relationship is connected by this right here, a constant. We all know that this constant is called pi, Pi, right? Pi. And we know that the value is 22/7 or 3.142 something. All right, so this is a constant. Let's use the letter K. We know that constant is spelled with a C, but let's use the letter K. So we have a constant called pi, which has a specific value. Now, a very long time ago, persons recognized the relationship between the radius squared, and the area of the circle, a very long time ago. And they realized that whenever you divide, or that relationship between the area and the radius squared, there was always a constant there. They realized that anytime you had area and divided it by the radius squared, you always got that same constant pi. All right, ladies and gents? Now, this is an example of direct variation. Now, with inverse variation, what do you think would happen? Well, with inverse variation, which would be a different equation from this, with inverse variation, as one variable goes up, it causes the other variable to go down. Ladies and gents, we're going to go for a break right now, and on the other side of the break, we're going to work a couple examples of direct variation and inverse variation. All right, so see you in a few seconds. See you on the other side. Welcome back to Business School. Again, I am your guest teacher for today, Lance McFarlane from Sophomore Academics, and we are looking at variation. All right, we're looking at now a question about direct variation. Here we have it on the board. All right, it says that if m varies directly as v squared, varies directly, pay attention to that, directly as v squared, and m is equal to 2 when v is equal to 3, calculate the value of m when v is equal to 6. Now, that very first statement, we need to get a hold of same time. It says, look at this, ladies and gents, look at this. M wow. The symbol. M varies directly as v squared. All right, this is the symbol for proportionality. All right, you are going to see the difference in how I write this when we are looking at the question that has to do with inverse variation. Ladies and gents, I want you to just soak this in. All right, M, this is literally read as M varies directly as v squared. M varies directly as v squared. So this really just means varies or is proportional. All right, so anyways, let's move from here. After writing this sentence, all right, this is what you do. Ladies and gents, that is reading m is equal to k times v squared. What does this k mean? I mentioned it in the first part of this tutorial when I was speaking about pi being a constant of proportionality. So here we have it, ladies and gents, k. All right, so once you hear that we have direct variation, you need to remember that this k exists. Now, after that, it's just quick calculation. This is the hard part, I promise you. At this point, what we're going to do, we're going to put in the values. It says when and m is 2 when v is 3, m is 2 when v is 3, so the value of v is 3, and we'll have right there being k. Ladies and gents, we just need to solve for the value of k first. Once you know the value of k, all right, just like how they found the value of pi, k, to be 3.14, we need a value for it. So this is saying 2 is equal to k multiplied by 3 squared. 3 squared is 9. So ladies and gents, we're going to divide both sides by 9. Dividing both sides by 9, bam, bam. Here we have it. The value of k is equal to 2 over 9. Now we know the constant of proportionality. Then we can actually now go and answer the question. It says calculate the value of m if v is 6. Remember, this is the equation. M is equal to k multiplied by v squared. They told us that the value of v is now 6. They want to know the value of m. Guys, we now know the value of k. We calculated that to be 2 over 9. So this is 2 over 9 multiplied by 6 squared. Therefore, m is equal to 2 over 9 multiplied by what is 6 squared? 36. And then you simply cancel down. All right, 9 into 9 goes 1 time. 9 into 36 goes 4 times. 2 multiplied by 4, ladies and gents, that is 8. Ladies and gents, simple as that. Remember, the process is, write the statement, m directly proportional or varies directly as v squared. You turn that into the equation, you have to include the k, the constant of proportionality. You need to know the value of k, ladies and gents. Just like we needed to know the value of pi, all right? We need to know the value of k. Without it, we can't solve the situation, all right? So after finding the value of k, using the information that they gave us, because they told us that m is 2 when v is 3. M is 2 when v is 3. You found the value of k, and then you use the value of k that you found to start over again. Put in the value of 6, the value of k, multiply across, you have the value of m. Ladies and gents, a beautiful example of a question on direct variation. We're going to go for a break right now, and when we come back on the other side of the break, we'll be looking at an example of inverse variation. This is Business School. See you soon again. Ladies and gents, this might sound cliche, but it's really all about practice, all right? You have to practice your mathematics, all right? So if you're strong, continue along. If you're poor, practice more, but you have to be practicing your math. That's my tip for you today, ladies and gents. Thank you. Welcome back to Business School. My name is Lance McFarlane, a math teacher from Sophomore Academics. We are doing the topic variation today. We're looking at direct variation and inverse variation. We did a question on direct variation earlier. Now we shall be looking at a question that is inverse variation. Let's go. This question says, given that y varies inversely as x. So we have two variables, guys, and they vary inversely. What this means is, as the value of one goes up, the value of the other will go down, inverse, opposite directions, all right? So given that y varies inversely as x, use the values of x and y from the following table to calculate the value of a. So here we have the table. It is saying, you guys all know how to read a table. This is saying when x is 2, the value of y is 8. And then it is saying that when x is 32, the value of y is, well, they don't know. It's a. So they put something there. We need to find this value of a. So y is a. They don't know what y is, so they just say y is a. All right, so let's go. Okay, so let's start with the very first sentence. Y varies inversely as x. Guys, how do you think you'd write that? Y, this is the symbol for varies, but now it's inversely. So what do you think we do at this point, ladies and gents? I know many of you got that right. If you didn't get it right, no problem. But this is the very first thing you need to know how to do. Write this sentence, this mathematical sentence then, that represents what was written here in English words. All right, so y varies inversely as x. That is what it says. So we wrote that here, which means y is equal to, I'm going to write this two ways. You'll see some persons write k times 1 over x. Or they can simply write it as y is equal to, because guys, what is k times 1? It's k. So you'll see them perhaps write it as y is equal to k over x. Either way is pretty fine. I stick with really and truly the second way. All right, straightforward. Now remember, we need to always know what the value of k is. K, right? They did not give us the value of k, so we need to calculate it. We always need to know that value of k. So let's use what they gave us in the table to find the value of k. We need a matching. We need matching numbers for x and y. Well, where we have here, when x is 2, y is 8. So we can use this. We can use this information. Plug it here into the equation. When y is 8, so we have y is 8 is equal to k, which we're trying to find, over the x value, which is 2. And then you just solve for k, ladies and gents. All right, many ways to do this. I'm just going to do a quick way. Guys, 8 is the same thing as 8 over 1, right? So I'm just doing some quick calculation here. 8 goes up to multiply, 2 goes up to multiply with 8, and we'll have 2 times 8, which is 16. We'll give you 1 times k, so we end up having 16 is equal to k. So the constant of proportionality, the k value, which is also important, we found it, and its value is 16. And we're going to use that information now to find the value of a right here. So let's go back to the equation. This equation right here. All right, this equation. We know y is equal to k over x. K over x. Now, guys, we know the value of k. We calculated it to be 16. The value of y is unknown. All right, it's just 8. We don't know the value of y. The value of x, we know it to be 32. 32. All right, so guys, this one is easy. A is therefore equal to 16 over 32, or a half. 16 into 16, 1. 16 into 32 goes 2 times. So the answer, ladies and gents, the value of A is a half. So that's it, ladies and gents. That is our answer, and that's our topic for today, variation. We looked at both direct and inverse variation. We worked a couple questions. That's it with us here today on Business School, ladies and gents. My name is Lance McFarlane. Stay tuned for more from Business School. Thank you.